Hey calculus kiddos, here it is. This is the last section that we need to cover for college calculus. So after this, all we have left is the chapter 9 test and our final exam. I'm super sad. You will notice that we jumped to 9.5. We did get to skip 9.4 because the concepts covered in 9.4 are actually calculus 2. So we go from 9.3 to 9.5. What we are covering in our last section of college calc, it is an application of the integral. So again, we're looking at an antiderivative, and what we're calculating is called the present value of a continuous stream of income. Okay, now the reason why this came way at the end, in order to calculate this, there will be scenarios where you need integration by substitution or integration by parts. So we did have to cover these two methods prior to looking at this application. Okay, so it is just a formula. We are calculating what's called the present value. It's a definite integral where my t sub 1 and t sub 2, they're the years. So it's the time period of the income stream. So again, it's going to be the least amount of years to the greatest amount of years. Now, K of t is the dollars per year. It's the annual rate of income. So how much money, maybe if it's an investment, how much money are you putting in at an annual rate? So every year. Sometimes this is a number. If this is a number, the process is super easy. But there are times when K of t is going to be a function. If K of t is a function, that means that we will have to do integration by substitution or integration by parts in order to make our calculation. Now it's e. Remember, e is a number, not a variable. So e will be there too. The negative r is the annual interest rate. This will be a percentage. Again, make sure you turn it into a decimal. And then t is our variable. Okay, we are doing an antiderivative based off of your variable. This is going to be a t. T represents the time in years. Okay, let's just go ahead. We'll fill in the values as we do this. Now the first one, it is a basic one because you'll see when we look at our K of t, it's going to be a constant rate, which means it's just a number. So super cool. A continuous stream of income is being produced at the constant rate of 60,000 per year. So that's what K of t means. How much is that constant rate every single year? For us, it's going to be 60,000. Find the present value, that's what we're calculating. Find the present value of the income generated during the time, 2 years to 6 years, if the interest rate was 6%. So let's go ahead and figure out our formula. So it's t sub 1 up to t sub 2. So those are our years. So the smallest year is 2, the largest year is 6. Okay, so definite integral. Now it's K of t. How much is being invested at a yearly rate? It is 60,000. Now it's e to the negative r. R is the interest rate as a decimal. 6% is 0.06. Our variable is t. 100% of the time it will be t because even the formula says find the antiderivative with respect to t. That's all that this formula is. Okay, now the reason why this one is much easier than what's coming up is because this is a constant. I can use the constant multiple rule, bring that 60,000 out front. My antiderivative goes from 2 to 6, but now it's e to the negative 0.06t dt. So my 60,000 is out front. When you're finding an antiderivative of an e term, you keep the e term the same. Now you just look at the exponent, and I find the derivative of that. It's a negative 0.06. You divide by that. So it's 1 over negative 0.06 plus c. Now what I want to do is simplify this. I can multiply those two together. Remember, this is top times top, bottom times bottom. So the 60,000 would go on the top. It would technically be a 1 underneath. So what I'm doing is taking 60,000 divided by negative 0.06. And when you do that, you get negative 1 million. E to the negative 0.06t plus c, and we're going from years 2 to 6. So now it's fundamental theorem of calculus. If I put in a 6, I have to go ahead and find that value. If I put in a 2, you have to find the value and then subtract. Again, this is something that I can do at one time. Negative 1 million. 1, 2, 3, 4, 5, 6. Make sure you get all of those zeros. Second ln gets me my e. Negative 0.06, I'm filling in a 6 for t. So this is how you would enter that. And I have negative 697,676.326, so 33, plus c, minus. Now here's the cool thing. If you were careful and you entered this carefully right away, all I have to do is up arrow. I am changing the years from 6 to 2. So I can just put the cursor on the 6, change it to a 2, hit enter, and I have a negative 886,920.44 plus c. Fundamental theorem of calculus, last step, I just have to go ahead and minus. The c's, remember, will always cancel because this is a positive c minus a c. This cancels this. Minus and negative becomes a plus. So if I take negative 697,676.33 and I add it to 886,920.44, I end up with 189,244.11. That is your present value and you are done. So again, it is just a formula that you have to fill in reading a real life scenario. Okay, let's go to one where it's going to get a little bit tougher, okay? It says a company estimates that the rate of revenue produced by a machine at a time t will be 5,000 minus 100 t dollars per year. So this is K of t. Notice the difference. Here, K of t, every single year it was 60,000. Well, it's going to change from year to year, so it's a function. It's okay for your K of t to be a function versus a constant. And this is why we'll need those advanced methods of solving integrals. And we're going to keep going. Find the present value of this continuous stream of income over the next 4 years. So what that means is you're starting now and going up to 4 years. So I'm going 0 to 4 because it's over the next 4 years. My K of t is 5,000 minus 100t. It's e to the negative. The rate is 16%, so it's 0.16. My variable is a t dt. Now this time I don't just have a constant that I can take out. I have to look at either integration by substitution or integration by parts. I don't see a composition at all. So this is going to be integration by parts. And again, that formula, we'll have to figure out an f of x, multiply it by the antiderivative of g of x, minus, then we'll take the integral of the derivative of f of x times the antiderivative of g of x dx. Okay, so we're doing integration by parts. The first piece is our K of t. So it's 5,000 minus 100t. G of x, this is similar to the product rule. So remember, f of x is first, g of x is second. It's e to the negative 0.16t. Now I have to find the derivative of f of x because that's what's in our formula. The derivative of f of x, well, 5,000 would be a 0. Negative 100t is going to be negative 100. Antiderivative of g of x, this is an e term. So it's e to the negative 0.16t. Now you take the derivative of the exponent, and it's 1 divided by negative 0.16. I can turn this into a number. That way I don't have to deal with fractions the whole time. If you take 1 divided by negative 0.16, you'll see it's negative 6.25. E to the negative 0.16t. It's an antiderivative, so I'm making sure that I put that plus c. Now I got to go ahead and do my integration by parts. Again, I'm not going to try to make this thing look pretty. I'm going to keep it as 2 separate pieces. Like the last section, 9.3, I had the one that was kind of crazy like this. I'm just going to do this the same way. So f of x, I'm just going to keep it 5,000 minus 100t. I'm not going to worry about trying to combine them. This is negative 6.25 e to the negative 0.16t minus my antiderivative. I have to multiply negative 100 times my antiderivative. If I take negative 100 times a negative 6.25, negative times a negative is going to be positive. 100 times 6.25 is 625 e to the negative 0.16t dt. So I'm going to grab a separate sheet of paper because you can see it's already kind of getting a little wild. Okay. I'm going to take this out. The 625, that's a constant. So I can use that constant multiple rule, bring it out front. So I have f of x, not changing it. One of the challenges here, at least for me, is when you're rewriting so much of the stuff, is to not make a mistake and rewrite it incorrectly. Okay. Minus, I'm going to take that 625 out front, so that way I have the antiderivative of e to the negative 0.16t dt. 5,000 minus 100t minus 6.25 e to the negative 0.16t minus 625. Now let's find that antiderivative. It's an e term, so you keep the e term the same. Because it's an e, now what you have to do is look at the exponent, find the derivative of negative 0.16t, which is negative 0.16, but it's an antiderivative, so I'm dividing. So my negative 0.16 goes under 1, because I have to show I'm dividing, plus c. Now what I can do is multiply those two together. So really, when you picture this, this is like negative 625 over 1. So top times top, bottom times bottom. I'm taking negative 625 and dividing it by negative 0.16. So let's go ahead and do that. So 5,000 minus 100t times a negative 6.25 e to the negative 0.16t. If I go ahead and simplify this, what I ended up with is a positive, because negative divided by a negative, 3,906.25 e to the negative 0.16t plus c. So this is my antiderivative. So look how much that stepped up from the previous problem, just because k of t was a function versus a constant. Now again, fundamental theorem of calculus, this says find the present value of the continuous stream of income over the next 4 years. So from now until 4 years. So we're going from 0 to 4. So I have to go ahead and put in a 4, then put in a 0. Now this is a lot of calculations, you guys. So what I'm doing, I'm going to try to go in little chunks, because I don't want to do all of that at one time. That would be absolutely insane. So I'm going to go ahead and put in a 4 here. So if I have 5,000 minus 100 times 4, this would be 4,600 times, now I'm going to put in a 4 here, negative 6.25 e to the negative 0.16 times 4. That's negative 3.29557, so I'm going to round it, and now right away this is going to be an approximate solution, okay? So I put in a 4 for this piece, put in a 4 for this piece, plus, now I'm going to put in a 4 for this piece, 3906.25, got it, e to the negative 0.16 times t, which is a 4, 2059.7360 plus c. Okay, so now I can go ahead and put this in the calculator at one time. So 4,600 times negative 3.2956. Then I'm going to add 2059.736, and this is negative 13100.024 plus c. Holy smokes. Okay, here we go. Now I have to go back and do this with a 0. So this whole thing was just f of 4. I put a 4 in here, and that's what I got. I put a 4 in here, and I got negative 3.2956. Plus, I put the 4 in here, and I got this. Okay, so I replaced all of the t's just one section at a time with the 4. This is what I got. Minus. Now I need to do the same thing with the 0. So I'm going to go ahead down here. If I put in a 0 here, 5,000 minus 0, well, this is going to be 5,000 times. Now here, if I put in a 0, 0 times 0.16 is going to be 0. E to the power of 0 is 1. 1 times a negative 6.25 is going to be negative 6.25. Plus, same thing here. If I put in a 0, 0 times negative 0.16, this is going to be 0. E to the power of 0 is 1. 1 times 3,906.25 is going to remain 3,906.25 plus c. So now I can go ahead and combine that. So I have 5,000 times negative 6.25 plus 3,906.25. This is negative 27,343.75 plus C. Here is your final answer. C minus C cancels. Minus a negative becomes a plus. So if I take negative 13,100.024 and I add it to 27,343.75, our present value is approximately, obviously we had to round throughout this whole process, so 14,243.73. Again, depending on how you rounded and where you rounded, this could be, your sense could be a little bit different. As long as you state that it's approximately, and you should be around that 14,243, 14,244, somewhere around there, you're good to go. When you end up with problems like this, like if you look at my work here, like from when I practiced it, I did end up with a 10-cent difference because I ended up showing more values here. So that's why when you're doing problems like this, you are going to get that approximate answer. So it's very important to know that you're estimating. Okay, let's go ahead and try two more. Two more examples, you guys, and you're done with calculus. Crazy. Okay. Oh, you guys, this is so crazy. You're going to do something right now that you've never done, and it's so fun. So we're going to find the present value of a continuous stream over the next 4 years. Okay, so over the next 4 years, 0 to 4. Sorry, I just remembered this problem, and it's so fun. Okay. The rate of income, this is the rate, and it's $1,000 per year. So we have to make sure that at the end, we do label that it's going to be in thousands. But again, this is per year. So that means this is my K of T. Every single year, this is how much that is being invested. But again, it's in thousands. So K of T is 25 e to the negative 0.02 t. Then it's times e to the negative rate. 8% is 0.08. Your variable is t dt. So think back of like algebra 2. If I had 3x squared times 4x to the power of 3, you can combine these because you had the same bases, right? The base to the exponent is an x. So you'd multiply the numbers 3 times 4, you get a 12. X and x, you would only show one x because you're multiplying. You add the exponents, making it a 5. You get to do that here because your bases, what contains the exponent, it's the same. It's an e. So it's the same concept as this. I can multiply these two pieces together to form just one function. Check this. So 0 to 4, this has an unwritten 1 in front. So 25 times 1 is 25. My common base is e, so you only write it once. You're multiplying, so you add the exponents. If I take negative 0.02t plus negative 0.08t, I get negative 0.1t dt. Here is your problem. So stinking fun. I got so excited when I did this last night. All right, now what I want to do is go ahead and take the antiderivative. So 25 is a constant, bring that sucker out front. So 25 goes out front. I'm going from 0 to 4 because it's over the next 4 years. That leaves me with e to the negative 0.1t dt. Now what I have to do is find the antiderivative. Don't forget that 25 is out front. This is an e term, so you leave it. E to the negative 0.1t, find the derivative of the exponent. The derivative of negative 0.1t is a negative 0.1. You're dividing by it. So it's 1 over negative 0.1 plus c. Now I can go ahead and simplify this. So if I take 25 divided by negative 0.1, you get negative 250 e to the negative 0.1t plus c. We're going from 0 to 4. And go ahead and fundamental theorem of calculus. This is something I can enter at one time, you guys, because it's just one nice little piece. Negative 250 e to the negative 0.1 times t. First, we're putting in a 4. I have negative 167.5800, so I'll stop right there. Minus. Now, if I just up arrow, I am changing, sorry, the blare of my kitchen light. Okay, if I want to change my 4 to a 0, you just put the cursor on the 4, change it to a 0, hit enter. Now it would be a negative 250 plus c. The c's always cancel. Positive c minus a c. Ooh, minus a negative turns into a plus. So my answer, negative 167.58 plus 250, it is 82.42, but remember it's in thousands. So it's thousands, or, so you could stop right here, or you could say, okay, well, if I have 82.42, if it's in thousands, that just means I move the decimal to the right 3 places. So I go 1, 2, 3, add a 0, and you could state that it's approximately 82,420. So either way, you could stop here and just remember the thousands, or you could actually move the decimal to represent the thousands and give this as your final answer. Okay, now I thought this was so fun back in the day when I first wrote these notes that I did a second one. Okay, so I hope you enjoyed that as much as I did, because we're gonna do it again. Last question of you learning something new in calculus. Take a big breath, give yourself a big hug from me. We got this, let's do it. A continuous stream of income is produced at a rate of 20 e to the power of 1 minus $0.09,000. So again, we got a label. $1,000 per year. This is K of T. This is the rate per year. Time of T, so that is our variable. And the investment is at 6%. Write a definite integral. You guys, definite integral just means that you have the number on the top and the number on the bottom. Okay, so write a definite integral that gives the present value of this stream of income over the time where T is 2 to 5. So the first part, and I did this because some of the suggested assignments in the book, they separated as A and B. A is like, okay, let's just write this. And then B is like, okay, now let's solve it. So that's why I had it this one like this. So I'm going from 2 to 5. K of T is 20 e to the 1 minus 0.09 t. Then it's e to the negative rate 0.06 t dt. So that's all that would be for A. You just wrote out the present value function. But now when you want to compute it, here are 2 terms that have the same base. Your base is E. So I can go ahead and multiply this. I'm going from 2 to 5. Okay, that's my definite integral. 20 times an unwritten 1, 20. This is a base of E, this is a base of E, so you write a base of E. Now you add the exponents together, so you're combining like terms. I only have one constant, so it is a 1. Negative 0.09t plus a negative 0.06t is a negative 0.15t dt. There is your formula. 20 is a constant, so I can use the constant multiple rule, bring that 20 out front. I'm going 2 to 5, e to the 1 minus 0.15t dt. I have 20 out front. Find the antiderivative. This is an E term, so you keep E the same. E 1 minus 0.15t. Find the derivative of the exponent. It's negative 0.15. You divide by that. So 1 over negative 0.15 plus C. Simplify this. 20 divided by 0.15. Now this is, you get like negative 133 and 1/3. So I'm going to go negative 133 point, I'm going to round it to the 100th. 33. E to the 1 minus 0.15t plus C. We have to evaluate it from 2 to 5 because that's what our values were from our antiderivative. F of 5 minus F of 2. Again, this is a nice easy piece that I can go ahead and put that 5 right into. Negative 133.33 e to the power of 1 minus 0.15 times 5. I got negative 171.1991 plus C minus. Now I want to change that 2 from a 5, or change that T from a 5 to a 2. So I can calculate F of 2. So I'm going to up arrow, go ahead, find where I have that 5, change it to a 2, and I have negative 268.4936 plus C. Now again, depending on how you're rounding here, your answers are going to vary a little bit. So if you round it to the 10th, if you round it to the 100th, to the 1,000, that's fine. It did not give you directions as to how they wanted you to round. That's why you just have to realize that your answer is going to be approximate, because everybody probably is rounding a little bit differently. Let's find our final answer. Positive C minus C cancels. Minus a negative, turn it into a plus. So negative 171.1991 plus 268.4936. Go ahead and write out your final answer. I have 97.2945. That is in thousands. So I could go thousands and call it good. Or I could go 1, 2, 3 and say approximately $97,294.50. So either way is fine, whether you want to move the decimal or keep it the way it is and label it in thousands. So guys, that was it. We just officially finished college calculus. You have learned everything that you need to for the year to get your credit. I'm very proud of you. I know this really stinks that we had to do the last little bit online where we couldn't see each other, but hey, we made it through. Proud of you. Give yourselves a big pat on the back and a huge hug from me. Your suggested assignment, there's only 4 questions to try. It is just finding this present value. I hope you guys are doing well. I miss you so much. Take care.